All right, so let's go back to our problem. If we know the sine value of an angle, how do we find the other trig function values? Great. So first things first, we definitely need to make the leap between sine and cosine. So we know that sine squared theta plus cosine squared of the same angle theta always will have to equal to 1. Okay, so the sine value is 3/4, right? That's given. So out of this equation right here, I'm going to find the cosine value of it. Okay, so that's going to be 9/16. Minus it over. That's going to be, 7/16, right? That adds up to 16. 1 minus 9/16 is 7/16. Great. Now, take the square root on both sides. Okay, so remember, the square root property always gives you two answers to this quadratic equation. So you have to write plus or minus. Now here comes the key important fact. How are you going to decide on the sign? Because it should just be one answer. Right here, we were told that theta is in quadrant 2. What do we know about the cosine value of an angle in quadrant 2? We know that cosine of an angle in quadrant 2 is a negative. So this is where I get to choose the sign. Sure enough, I'm going to do one more thing and simplify this by taking out the 16 outside of the square root symbol, right? So that's a square root of 7/4. Good. So what I like to do is write this. Even though I know already the sine value, I'm still going to write it there. So sine, cosine, tangent, and then here I'm going to write their reciprocals. Cosecant, secant, and cotangent. So what was the sine value? 3/4. What was the cosine value? Negative square root of 7/4. How do you find the tangent? Divide the two. Yes, so negative 3 divided by the square root of 7, which can also be rationalized, and you should be rationalizing these. 3 square root of 7/7. What is the cosecant value? It's the reciprocal of sine. What's the secant value? It's the reciprocal of cosine. Same thing, rationalize this. So 4 square root of 7/7. And what's cotangent? The reciprocal of tangent. So negative square root of 7/3. Boom, done all of it. Okay, let's see. Tangent is actually a tricky one. If we start with that, so if I know the tangent value, what could I find? Well, sure enough, the cotangent immediately. But what I need is that leap to sine and cosine. And tangent is sine divided by cosine, but that doesn't mean the sine value is 7 and the cosine value is 10, because remember, the sine and the cosine can only take values between -1 and 1, right? So one trigonometric identity that we had told us that 1 plus tangent squared is equal to secant squared. So here I'm making my leap from a tangent to a secant, and secant's the reciprocal of cosine, so that's how we're going back to that. Okay, so this is what I'm going to do, solve this equation. Squared. There's a better way or a faster way I can show you once we talk about 5.4. I like that way better. But you'll have to wait for that. So that's 149/100, by the way, right? Add these up, secant squared. Take the square root on both sides. Don't forget to put plus or minus. And I'm going to simplify this and already take out the 100th as a 10. So it's secant of theta. So there I have secant of theta. How do I know which sign to pick? Well, theta is in quadrant 4. What happens in quadrant 4? In quadrant 4, cosine is positive. So if cosine is positive, so is its reciprocal, right? So the reciprocal of cosine is secant. That's going to be a positive too. So I'm going to write them all here, and then we're going to start filling them in. Sine, don't forget about the theta, even though I don't quite say it. But don't forget to write theta. I'm going to get super mad if you do. Okay, so which ones do we know? We needed 2. Tangent is negative 7 over 10. So if tangent's negative 7 over 10, cotangent's negative 10 over 7. Secant, we found its square root of 149 positive over 10, yes? So cosine's the reciprocal of that, which is 10 divided by the square root of 149, yes? So how do I find sine? And from sine, cosecant. Remember, tangent is the reciprocal of sine over cosine, so I'm going to say that's easily negative 7 over the square root of 149. Why? When you divide these, the square root of 149 common denominator goes away, so you're left with negative 7 over 10. You can do the whole identity. In other words, what? Tangent sine over cosine, right? You know tangent and you know cosine. To get to sine, all you have to do is multiply the 2 of them. So when you multiply the 2 of them, see, the 10s go away, and you're left with negative 7 over the square root of 149. Easily done. And then finally, the cosecant's the reciprocal of sine. And one more thing, I need to rationalize these 2. Okay, rationalize nicely. Okay, well that's it. There you go. That's your answer. So, this is how you can use these trig identities to, if you know one of the trig function values, you can find the others. Now, what's even more fun is to put all these trig identities that I put on one page for you nicely to simplify trigonometric expressions. If anything, that's going to be the most important thing, really, that you're going to be using in calculus. So, why? Well, you're going to have to manipulate all sorts of trigonometric expressions, right? Functions, trigonometric functions. You're going to have to take the derivative of a function that might look like this. To take the derivative in this format will take you a while. It will be quite difficult. So what we want to do all the time is, can we simplify this? Can we make it better looking? And then I can deal with it better. So how do I use the trig identities to simplify the expressions? I'm going to put it here as a hint, and that would be to try and rewrite everything in terms of sines and cosines. By the way, that's the actual name of sine. I know we write sin, but it's sine. That's the name of the function. Okay, so try and rewrite everything in terms of sines and cosines. Why? Most trigonometric identities, right, refer sine and cosine with respect to everyone else with respect to sine and cosine. So let's see what I got. Secant is, of course, the reciprocal of cosine, yes, minus tangent, using the ratio identity, is sine over cosine times sine theta. Well, sure enough, again, when you multiply these, right, multiplication before the subtraction, this means over 1. So I can write this as 1 over cosine theta minus sine times sine is sine squared theta, right, over cosine theta. Okay? So what else could I do? Now I am supposed to subtract 2 fractions. I need a common denominator. Oh, yay, I have a common denominator. Okay, so this might actually look a little bit worse, but it's way better. Can we do one more thing? Now remember that most important Pythagorean identity that relates sine squared theta to cosine squared theta. Every time I see a sine squared theta or a cosine squared theta, squares, right? I think of that identity and I know I can turn one in terms of the other. So sure enough, from the cosine squared plus cosine squared is equal to 1, 1 minus sine squared is the same thing as cosine squared. And it's just the same as having an x squared divided by an x, right? That's the square value of a cosine divided by the value of the cosine. That's just one cosine. So definitely way better looking than the beginning, right? Way simplified. Okay, let's try this again. That's a lot of fun. Okay, secant is 1 over cosine. Cotangent is cosine over sine. Cosecant is 1 over sine. Okay, so now that I rewrote everything in terms of sines and cosines, boom, it's algebra. So this is what this is all about. A little bit of trig, a little bit of algebra. I rewrote everything. Now this is algebra, right? Multiply fractions, add fractions with a common denominator. Again, 1 minus sine squared, that's cosine squared. That's a trig identity, yes? And reducing this fraction is back in algebra. So I rewrote everything using my identities. Now I'm going to use some algebra, and these two will cancel out. So I'm left with a 1 over sine theta over 1 over sine theta. Well, that's not much work to be done. That's a 1, that's for sure. Divide a fraction by itself, right? Of course, multiply by the reciprocal. That sine theta goes away, so you'll be left with 1. Definitely much simpler than this. Okay, let's try this again. Cosine is cosine. I'm not rewriting that. But secant is 1 over cosine. Sine, plus. Sine is sine. I'm not rewriting that. But cosecant is 1 over sine. So, rewrote them in terms of sines and cosine. Great. What can I do? Now remember, when you take a fraction or anything and divide it by a fraction means to multiply by its reciprocal. So what this equals to is cosine theta. To divide by 1 over cosine theta means to multiply by cosine theta over 1 plus sine theta times sine theta over 1. And sure enough, what's cosine theta times cosine theta over 1? That's the same thing. Cosine times cosine is a cosine squared value over 1. So itself plus sine squared theta. And by the way, have you seen this before? Sure enough, that's our Pythagorean identity that adds up to 1. Again, way simpler than the beginning. Right? Okay. One more. Let's see if this is going to be just as good. So I have 1 plus 1 over cosine theta over 1 plus cosine theta. So, not just as pretty, but we've used this trick ever since chapter 1, pretty much week 1, that if you have what's called a complex fractions, right? Fractions within fractions, what you might want to do is multiply top and bottom by the least common denominator of the one fraction you want to get rid of, right? Which is this one. You shouldn't have fractions inside fractions. Okay, so I have 1 times cosine theta, which is cosine theta, plus 1 over cosine theta times cosine theta, which is 1. And this I'm not going to distribute. I'm going to leave it like that. Because what do you notice? This whole chunk in the numerator is the same thing as this whole chunk in the parentheses in the denominator. Addition is commutative, so 1 plus cosine theta is the same thing as cosine theta plus 1. So this whole factor, right, gets to be reduced. So I'm left with 1 over cosine theta, which is the same thing as secant theta, right? Just I don't want to, I can rewrite it. It's better than having a fraction, right? So it's all down to something super easy. expression only. Okay. So, I'm sure you remember from your trig classes that you've also had to do something called proving the identities. These problems are in fact much easier than what we've just done because your answer is there. So it's the same thing as me asking you, hey, this is what you need to start with, right? And I'm telling you to keep on simplifying this expression until the answer is 1. So prove that this equals to 1. How would I prove that this equals to 1? Well, I go and start simplifying and simplifying until I get to 1. So the nice thing about these problems, or these proving the identities, is that we are telling you what the answer is supposed to look like. So in other words, keep on simplifying. Don't stop. Don't be like, oh, this looks good enough. No, just keep on going because your answer will look much better at the end. You will be able to simplify it all the way to a 1. So that's what we're saying here. That you should be able to simplify this expression until you get to this, or simplify this until you get there. The point is, we definitely could rather simplify a more complex, ugly expression to a shorter one than make a short one look this long. So when you have to prove an identity, as a rule, well, not necessarily as a rule, is what you could do is you always start maybe with a more complicated side, try and make it look like the easier one. So I'm going to start with this side and see if I can make it look like this. How do I do that? Just like we did before. Turn everything to sines and cosines. Okay. So here's that. Sure enough, these are going to reduce. And I'm left with 1 over cosine theta minus cosine theta. So it says, keep on going, that I don't want it looking like this. I want it looking like that. Okay. So, okay, looks like I'm going to have to turn into one fraction only. So that means I'm going to need to subtract these two. And sure enough, if I want to add or subtract fractions, I need a common denominator. Yes, so I'm multiplying this by cosine theta. So what do I get? I'm going to get 1 over cosine theta minus cosine times cosine is written as cosine squared theta over cosine theta. And this might remind you of a problem we did on the previous page. Okay. And we did that with the 1 minus sine squared turn into cosine squared. And now what's 1 minus cosine squared? It's sine squared theta. So also, because we are giving you the answer, keep in mind to what format you want to get to, right? So you have to keep on simplifying it until you make it look like this one fraction with a cosine for its denominator. So again, as you see, a little bit of algebra, a little bit of trig every single time. All right, one more. By the way, we're going to get through this again in 7.1 once we've talked a little bit more about all this trigonometric function values and their properties. So we'll come back to proving much more complicated identities, which is getting our feet wet a little bit here, but we'll get back to this in 7.1. Okay, so we want to prove that this can be transformed into this expression here. Good. How do I do that? Again, try and start with the complicated side, or the uglier side. So secant 1 over cosine times sine theta plus cosine theta. Remember, you just want to turn everything to sines and cosines. Okay, and I'm going to distribute this. So what do I get? Well, sine theta over cosine theta plus cosine theta over cosine theta. Remember, these are over 1, so these numbers get multiplied to the top, right? This to the bottom. And that's easy because what's sine over cosine? It's a tangent. And what's a cosine divided by itself? Well, that's 1. All done, right? That's just how fast it is. So the nice thing about identities is that we are telling you when to stop, right? When have you reached your answer and what the answer is going to look like. Okay. One last topic for this section. I know it's quite a bit. I know I've spoken a lot, just wanting to make sure that you know exactly where I'm coming up with my answers. So I'm going to draw a unit circle for you one more time. We go back and forth to this unit circle all the time. So what have we learned about this unit circle? We've learned that if you have an angle, and I'm going to keep it simple, right? This coordinate here of this point is definitely the x-coordinate is the cosine value of this angle theta, right? And the y-coordinate is the sine value of this angle theta. What I want to do is, what happens if you go in a negative direction by the same angle theta? So negative theta, well, I'm going to still end up with cosine of negative theta and sine of negative theta, right? My angle now is not theta, but negative theta, but the point is wherever I end up on the unit circle, the x-coordinate is the cosine value of this angle, and the y-coordinate is the sine value of this angle. So what could you tell me? Of course, my picture should have been a little bit better, but what could you tell me about these two x-coordinates? I see very much that what? The cosine of an angle theta is the same thing as cosine of negative theta. Well, if you think back at chapter 1, when we talked about even and odd functions, and we said if you have a function, you plug in a negative x for x and you get the same answer, we'll call that an even function. So in other words, cosine is an even function. So what do I mean by cosine's an even function? If you plug in a negative angle, is the same thing as plugging in the positive angle itself. So cosine of 45 degrees is the same thing as cosine of negative 45 degrees. Or in other words, what? Cosine of negative 50 degrees is the same thing as cosine of positive 50 degrees. Okay, so that's what we're getting out of this. Whether you plug in a negative or a positive, same angle, the cosine values are the same. What can you tell me about the sine values? So if you plug in a negative angle, right, versus the positive angle, what do you think about these y-coordinates? That they're going to be exactly opposites of each other. So in other words, sine of negative theta is the opposite of what sine of theta is. Remember also, cosine's positive, right? First, fourth quadrant, but sine is positive here, but a negative in the fourth quadrant, right? There's a negative y value. So they're exactly the same number, but opposites of each other. So when this happened, we call this, so sine is an odd function. Okay? So when we get to chapter 6 and actually graph these functions, we'll see that the graph of cosine is symmetrical about the x-axis, whereas the graph of sine is symmetrical about the origin, right? So think about the x squared function versus the x cubed function, right? So it will be the same thing for cosine and sine. Okay, so cosine is even, sine is odd. What about the others? Okay, now sure enough, I'm going to write them here. Who is even? Cosine. And of course, it's reciprocal, right? The reciprocal of positive is a positive, so cosine and secant are even function. Which ones are going to be odd? Well, sine, of course, cosecant, right? It's reciprocal. And by the way, tangent and cotangent. Again, a positive divided by a negative is a negative. Yes, so when you plug in a negative theta inside the tangent, right, it's going to be negative sine over positive cosine. So that's a negative tangent, right? So all of these, only cosine and secant are even. The rest of them are odd. Okay, so in other words, anytime you see a what? Negative angle inside the tangent, what does that mean? It means you get to throw the tangent up front. So for example, or the same for all of these. So for example, what is cotangent of negative 30 degrees? Well, that's the same thing as negative cotangent of 30 degrees. So you get to throw the minus out, right? And by the way, what's cotangent of 30? It's the reciprocal of tangent of 30. So that's just the square root of 3. Okay, so yeah, that's how we use these even and odd. So sine, cosecant, tangent, and cotangent, throw the minus out. The cosine and the secant pretty much swallow it. What does that mean? That secant of negative 30 degrees is the same thing as what? Secant of 30 degrees, right? It stays the same. So it's like it swallows up the minus, right? What is secant of 30? It's the reciprocal of square root of 3 over 2, so 2 over square root of 3. 2 square root of 3 over 3. Rationalized. Okay. All right, this is enough for 5.3.